Do you think that there are still reasons why we might want to use RNNs instead of transformers for NLP?
It's a very good question. I mean, I spend a fair amount of time on both RNNs, LSTM, and I have an appendix on the GRU, the gated recurrent unit. So definitely I felt that I really wanted to have it there as a part of building up towards the transformer, right? And I would struggle with coming up with how can I just describe the transformer without describing how we got there with the encoder decoder networks and attention and these things. And there's a lot of buzzwords here now, but the transformer is pretty complex. So from a understanding perspective, that's how it made sense to me to describe it, which meant that I definitely needed to go through the details of RNNs and LSTM. And I would imagine that they will continue to have a place where that we will continue using them. I mean, people are using them, right? Transformers have been shown to be good at other things than NLP as well, computer vision, now vision transformers. Mm-hmm. Does that mean that we don't need convolutional neural networks either? I mean, some people would say that we really just need the transformer and then let's build on that. And maybe that's where we're going, or maybe we're going to, maybe a few years from now, we have some other architecture that has been, we have arrived at from having the transformer as a stepping stone. I really don't know.
Yeah.
But I think that they're kind of these building blocks that basic building blocks that you still need to know them. Like you need to know a convolution, probably need to know how a recurrent network works in order to then come up with even greater architectures. So maybe they won't be used just as is, because just like who uses just a single perceptron today? Not that many people, right? But they will be used as building blocks in other architectures and mechanisms from them, I think.
That makes a lot of sense. And something that is probably obvious to you, but we might as well state, is that one of the advantages afforded by CNNs or RNNs relative to transformers is that, for the most part, speaking in broad strokes, they are a lot less computationally complex. So they require less compute power, compute time, compute money to train and implement. And for a lot of real world applications, we don't need the most accurate or the most nuanced results. For a lot of machine learning applications, we'd actually prefer something to be fast and cheap and maybe a little bit less accurate.
And that you can understand it easier too, right? You don't necessarily need to use deep learning either, right? There are traditional machine learning techniques, and you should always consider them as well, because there's also the part of explaining how the system works. And so, yeah, I think you should learn a lot of different techniques and then use the right tool for the right task, right?